G'day, Michael here. This video is all about what I've got on the screen right now, and that's the best DOS-based legacy hardware and software support. Now, basically I've got some old machinery that requires DOS software to run. I've written the software myself years ago, built the machinery myself, but there are a lot of people out there, maybe that's you, that has some older equipment that still works fine, but requires like a DOS environment to work with it. But hardware is, coming to the end of life as far as computer hardware is coming to the end of its life, and perhaps operating systems now are not being supported, being abandoned by, say, Microsoft or whoever. And you're looking for some way of keeping all this going rather than throwing away what might have been $500,000 worth of equipment just for the sake of an operating system change. Now, this video is about a reasonably good solution. Well, it's been good for me, and may also be good for you. Now, it's just making me a little bigger. I've experimented with, well, over the years, for a start, I've used early Windows, like Windows for 286 was the first Windows I had. Maybe someone here remembers that, maybe I'm alone. Then Windows 2.0, 3.0, 3.1, 95, 98, ME, NT, 2000, XP, Vista, 7, 8, and 10. Now I've had a license for each one of those except Vista. I've probably got 7 and 8. I've probably got maybe 5 or 10 licenses of those, just that have turned up with machines I bought second hand and so forth. So basically I've got a license for every one of those versions of system that you see right there. I've also played with Mac. I bought a small Mac Mini to see what was possible with it. Plus I've played with a Hackintosh in a virtual machine to see what's possible with that. But yeah, what I've learned is it is very much a restricted audience now. You really are limited to what you can do. And I guess the best thing for me to do would be probably show you how the software works, but temporarily you can see there's a little blue dot here on the bottom of the screen. That's saying I need to do some updates. So I'm just going to install those updates while I'm doing this video. Okay, now I'm running Linux Mint Cinnamon. Oops, hold on. That can happen. Right, I want everything up to date. Not that those particular things matter, but I wanted everything up to date because we're going to install some software, and it's good to have everything just ready to go with the latest system libraries, etc. Okay, so now what the advantage of 286, 2.0, 3.0, 3.1, 98, 95, ME, they all actually use the DOS kernel. So the compatibility with DOS software was very complete. I'll expand on that later. But NT, 2000, XP, Vista, 7, 8, and 10, I want to say 9, but it doesn't exist, have what was called a Unix kernel. But if you have anything to do with Unix, you wonder where they even get that from. Certainly Microsoft has its own way of driving, and it's not like Unix. Mac and BSD can actually claim to be Unix systems because they are based on Unix kernels, really are. Now, the DOS kernels that were in the first lot of Windows environments was actually a native support because it was a DOS kernel. The later ones, there was kind of an emulation put on that. With Mac and BSD, they're Unix kernels completely, so again, it has to be like an application that's installed to give you that system. Now, Linux is the same. Well, it's really weird that Linux is kind of more Unix than the others are, even though it's not Unix. It's basically written in parallel open source clone of Unix. Now, I'm using the word very simply. It's probably, I'll expand on this just long enough to go away from it again. Really, we want to be using the word GNU plus Linux. Linux is the kernel, and Unix, the BSD kernel, is what's under Mac OS. That's the bit that runs the machinery underneath everything and then provides all the services to whatever software you're using. Alright, but from there on out, it's actually like the software that's installed on the system, and that's what the GNU is all about. And GNU is a recursive acronym for GNU's not Unix. Yeah, so, alright, now BSD interestingly enough, is the most like Linux. If you use something like Ghost BSD is an easy BSD to install. I've played with that as well to see what that was capable of doing. Technically speaking, there's no reason why it can't run any software that Linux runs, but it's a bit more tricky to get set up. Linux is a lot more sort of, well, it's easier for a layperson to use. Alright, so on all the systems you can use an open source package called DOSBox. Now DOSBox, let's just go and install that so you can see what I'm talking about. Put this on every screen. Right, let's go to another screen. Okay, so I'm just going to open a terminal, and if you're not used to using a terminal type environment, I don't like to see through business, so I'll just change preferences. I've only just recently installed this, so forgive me for a second. Go to the transparency, good to go. Right, if you're not familiar with using a terminal, you can open a terminal in Mac OS if that's what you're using, and type df, and you'll get a result like that. If you type something like ls, you'll get something like that. Things differ very rapidly from there. BSD will give you much the same sort of thing. This is very much its behaviour. So this is common across the systems, and Microsoft's becoming more like this. So if you type ifconfig in this machine, it shows you interfaces on the network. You do that in Mac OS, you'll see the same thing. BSD, you'll see the same thing. But in Windows, you've got to type in ipconfig. So you swap the F for a P, and it gives you the same kind of results if you open a command prompt. Okay, so you can see the systems actually have a lot in common, and if you want to get things rolling fast, there's a lot that's actually a lot easier to do in a terminal. So let's just install something. I'm going to get on as the administrator. So in Linux environment, using the bash shell, which is this shell that's running in this terminal. Sudo is a way of becoming administrator. Sudo su will keep me there. It's a lot to explain, but I'll just leave it at that. Sudo su, a password. So now you can see I'm root at, this machine's called mobile because it's on a trolley, arbitrary name. Root at mobile, I'm at my directory, home Michael. So that's my location. But if I go on apt install, this is now specific to this Linux distribution or Debian-based Linux distributions. Apt install, let's do DOSBox, DOSemu, and two other things that I just like having, Midnight Commander and Joe, which is an editor, text-based editor, that'll work inside this environment. Now you can see how I've used this to get on as administrator. Everything I do inside this window, I'm the administrator of the machine. So it's a very easy way of getting access to things while I'm still running as a client and everything else. Right, but it doesn't mean I'm capable of damaging the system at this level. So I could delete files that would do the system harm if they were gone. Much like you can do in a Windows environment. Okay. So that's going to go off and install. Now if I was going with a mouse-based system like pointy-clicky type arrangement, it would take me actually more time than typing that out. The machine's a bit busy. Let's see how busy the machine is. This is about a 15-year-old computer, so forgive it if it has little issues. Okay, so that's that done. Now let's just fire up DOSBox, which should be there, I'm hoping, any second now. There's DOSBox. Now DOSBox runs straight off the bat, it's very quick to boot, but the way of getting data in and out of that is a bit more complicated. Now let me just have a look at this. Let's do intro. Same to do intro, let's do that. Also DOSBox will just exit if there's an error that occurs, so it's a bit fragile. Yeah, okay. Okay, now if you make a directory called DOSProgs, or whatever directory you want to call it, go mount // tilde means your home directory, so in my case it's home Michael. So let's just, if I click on that, I'm at my home directory. home Michael, if I made a DOS progs directory in here and said every time I started the system up, or put it into the bat files, I could get it to boot up, mount a folder here, and it'd give me some access to the local drive. And yeah, so that's how you get files in and out of it. Now, DOS-EMU on the other hand, let's just fire up DOS-EMU. Okay. Now, as you can see, I've got two different emulators running here, and that causes no problems, except my CPU usage is a bit high. I'm going to have to close one, because I'm not sure whether this screen recording is going to be happy. Okay. You can see the DOS emulator's got this CPU core running on the roof. So I've got to ease up some pressure on it. What have I got going here? Hopefully it's not going to break on me. Alright, so now I happen to know for a fact that DOS-EMU has now, because I've run it, created files here in my home directory. But to see them we have to show the hidden files. Okay, now you can see DOS boxed in, and there's DOS-EMU, right? So the area of interest to us is DOS-EMU, drive C, and there we've got the virtual drive C. So any software we want to put on this system, we have to put in this location. And I prepared that earlier, so I just go to my file system, storage, drive C. Now I need to get that, those guys. So I just drag those in there. So whatever files you needed to have running in your DOS environment, you need to get them copied into that drive C space. And if there was any little batch files or whatever you had to execute software, that's what you'd need. So in a perfect world, I should be able to go in my DOS environment right now and go, there we go. So that's the program that's in this directory. Let's just see what we've got. Okay, what does that relate to? Okay, there's a command instruction here. So that's okay. So we've now got the DOS software running fine. But what about if you need to talk to serial ports? How does that work? Can we set this up so we can talk to a computerized machine? Like I have a computerized router. I also had a laser cutting system. They used RS-232 communication. So how do we make that happen? Now this machine doesn't actually have an RS-232 port. So what I've had to do, just grab the thing. This is a device designed to give you a USB port to RS-232. Now I'll just show you what that looks like. So that's an RS-232 socket, and that's provided by plugging that into the end of this, which is a USB cable connected to the computer, and then the RS-232 connection goes into this device. So it emulates RS-232 from a USB port. Now that will have done something on the system. Let's just have a look what it did. So I'll open another terminal and go D-message, DMESG, and it should show that. Unfortunately, because it was already connected as USB 1, it's disconnected and made it USB 0, it's now USB 1. I might unplug it and do that again. Before I unplugged it, it was a dev USB 0, dev TTY USB 0. So, alright, now, so it physically exists as dev TTY USB 1. You may have to change that if you unplug and replug like I just did. But let's just roll with that. Right. So how do we make the DOS emulator talk to that USB port, which then talks to the RS-232 device? Right, let's just close this. I've been to the future and it's full of errors. I missed a detail, and that is with the security permissions on a Linux system, they're very fine-grained. Various services, various pieces of hardware on the machine, even types of software you can access can be all set up with access permissions. So part of the reason why Linux is such a good, well, it's actually all the Unix, the decent Unix environments, have the same kind of level of security, and that's part of their strength, which is also an asset to running DOS software under it. So, all right, let me explain what I mean. The users. So there is only one user on this machine, and that's the user Michael. Okay, now Michael, let's see what he's allowed to do. He's in all these groups. But the one we're interested to get access to serial ports, RS-232 ports and USB ports, is, where are we now? TTY. That is the group that is assigned to access those parts of the system. Alright, so you have to enable that, and then log out, then log back in again, so as to have the user, in this case Michael, have access to whatever the group TTY has access to, which in this case includes the serial port. Alright, I think that's well enough said. Okay, back to the past. Right, so in the process of installing the DOS emulator, it's created some files. Now Linux, actually a lot of the Unices, keep a folder or directory called etc. So if I go cd etc, ls is list of files. You can see blue is directories, white are just files, green are executable files, and this cyan is for links that link to something else. Right, so they're like, you know, links you might have put on your desktop on Windows or something like that. You can see one here. This is a link also. Alright, so if I go cd DOS emulator, or DOS, okay, DOS emu, ls, there are three files of interest to us. DOSemu.conf, DOSemu.users. So I'm going to go mc edit DOSemu.conf. Right, so I'll just go at the top. It's a fairly sizable file, but it is written in plain English, and you can go searching for whatever it is you're looking for. Now of interest to me is COM ports, so I'll just go F7, COM1, okay, here we go, closer, oh, there we go. Now I've already set this one, I have had this installed before, so it's kept the settings that I had it installed previously, but now we've got dev TTY USB 1, which is unfortunate, but it's re-enumerated at dev, it's wrong one. So I have to change that here. Next time I reboot, I'll have to change this back to 0, which would have been okay if I left it alone. Okay, now what was important is you have to get rid of, there will be a crosshatch in front of the COM1, like there is in front of the COM2 here, for argument's sake. You have to delete that, so the $sign is right at the front, so equivalent to doing this, right? So COM1 is that TTY USB 1, and the low latency allows like better communication in and out from the DOS emulator through to the RS-232 connection. It's a better, it doesn't break as much. I've had the most reliable results out of that. Okay, so what else do we need to do? One of my DOS programs requires access to printers. So let's go down and look for printers. I missed one. What do I do? Oh, here we go. Printer support. Now these will be commented out by these crosshatches. This is how they appear when you start, and they may have, like, I think it was just LPR-L was all it had. Now it explains here, LPR-L means basically no driver, so it's just transfers the data straight from the DOS program straight to the printer as if there's no driver. So if you've got an old-fashioned DOS matrix printer, or a golf ball printer or something like that you use with the DOS program, that'll just run straight directly to it without any interpretation. The data won't be changed in any way. It'll be sent literally as asked. Okay, but that means your printer has to want that kind of information. If you're trying to print text from the DOS environment to, say, a photo printer, the photo printer may not know what to do with the text. So you need something to render the text into like dots to be put onto the page. So that's an important distinction, whether the printer is happy to just take text from the DOS program, or whether it needs to have some sort of graphics, or whether it has to interpret text into graphics. That's an important detail you'll have to know yourself, or at least play with it. Some printers support, some modern printers actually support printing text. Now I have a Lexmark, it's a few years old now, but it's capable of supporting 3 types of data: plain text, and it'll put plain text on the page. It also supports PCL, which is a graphical printer language, printer control language by Hewlett-Packard. It also supports PostScript, which is really the foundation of most graphics printing software. In any case, what I've got for this particular printer that I've got, which supports all 3, is I'm just passing from the DOS program directly to the printer because it supports everything I need it to do. So no driver. Which printer? Lexmark. Right. LPT2, which is like printer 2 port, be like the physical second printer port on a computer. I've set up basically the same. I send PostScript work from a DOS program to the printer, and the printer itself renders it. If you needed the PostScript rendered into like a photo printer, you'd simply get rid of the -L there, the -L, and then you end up with it being sent through Linux's printer interpreter, and then it gets sent out the other end as a graphic for the printer. Hopefully that's not too heavy for you. But basically, this is where that happens. If you have a situation where you're trying to resolve this and you have a question, leave a comment. Leave a question in the comment. Maybe I'll be able to give you a hand to get through that. Alright, now I'm not in this video showing you how to install Linux or set up network service, because that's another subject and it's already long enough, this video, so I want to keep it as simple as possible. Let me know in the comments if you want some help there. Alright, we'll move on. So that's what this thing is set up for. I'll go save, quit. Right, so if I fire up DOSEMU now. Okay, so I'll launch DOS emulator, add it to the panel, so I don't have to go looking for it all the time. There we go. There's the DOS emulator. So if I run my robotics software, happy days, it's all running. So if I tell the machine to home, everything's happy, yep. You can see there's a little bit of activity down the bottom here. And we now have a DOS program running underneath Linux, talking to the robotic system of my computerized router. So here you can see a productive machine working quite smoothly. Now it's using, there's a file that it's going to be loading from d:/server, which is my server across in the office. Now let's just have a look at that server. It's got 1.2 terabytes of free space. It's a 2 terabyte drive. DOS has got no way of handling 2 terabytes of data. 2 gigabytes was a 16-bit DOS limit. So it's very interesting that we now have access to terabyte file services from the DOS environment because of DOSEMU. I found that to be very interesting in its own right. I'm also talking across the serial port to the computerized machine right now. It's still active. I might actually get it to launch a cut. I'll turn the motor on so you can actually hear it squeal. Okay, so the compressor's full. These are the details about this machine. It's an Athlon 2 640 processor. It's a quad core, no hyperthreading, just quad core. I think it's about 15 years old. It's certainly not a new computer. It was a good computer for its day, but it's actually quite old. So you can see Linux is running this quite well. It's even being able to afford screen recording at this resolution. I've got an Office package running. Let's go look at we've got the DOS environment running. Hopefully it's holding together. Alright, so let's just use this thing. Now it's using RS-232, which is fast enough for the tool, because the tool can't move that fast anyway. As you can see, the DOS graphics is working fine, and that's very noisy, so I'm going to turn it off. Okay, so that's a bit quieter. You can see that's the tool, the yellow X and the green marking where it's been. So yeah, so you can see it's all in action, it's working fine. Alright, so let's just get out of there. Let's get it to stop. Go to the same place. Okay. So now you can see the tool's moving off out of harm's way. It's a slow machine, but it's fast enough for the job at hand. Right, so let's just get out of that program. Let's try something else. I'm not sure it's installed, so let's go through the process of installing some new software on my DOS environment. Okay, so I'll use Midnight Commander to copy, show you how this works. You simply use the up and down arrow to navigate to where you're after. Press enter on whatever it is you're looking for. Computer, and DOS. Cut list is what I'm looking for here. Let's go to our DOS emu, drive C. Cut list. Now here's the bit that's quite elegant with Midnight Commander. Let's copy it. Now if it sees something there, you've got the option of overriding the target, adding to it, overwrite all targets, update. Now I'm going to go update. That way it only copies the new files that don't exist on the destination target. There was a problem with copying it before and I don't understand why, but here we go. Copied. Okay, so that's now there. If I was to run, I'm not sure that's fully set up, so let's see how we go. I need to get a batch file to run that. So what I'll do is what does that look like? F3. Okay, it's a typical DOS batch. I'll just change it. Okay, so I'll create a DOS batch file. Now we can do this a number of ways. We can actually use the DOS editor. So I could type in something like edit c.bat, and we're in the DOS editor, which we can do, or we could use Midnight Commander's editor, or I could just go FX. I can simply browse to it the other way. DOS emu, drive C. I might just actually open with, like Joe, I'll use, it is right there in front of me. Okay, let's do that. Here's that. So I'm going to save as, give the kit a new name, we'll change it to c.bat. Okay, so cd backslash, it's the folder, cut list, CUT, LIST, don't need all that. What's the program I need to execute? Blimey. Cut up 3 probably. I hope that's the right one. Okay, let's try that. Save. See. Okay, so let's create a new cutting list. Let's do that. So edit. Fred's our customer. Job known. Test. 24. Oops. Let's get one of those. Might get change width of that one. 650. Number of adjustable shelves. D. Right. That's 2. Plenty of tests anyway, so let's do that. Escape, escape. So let's create all that. Okay. Let's save that as a test file. Optimize it. Okay, so let's optimize the sheets. The 4 sheets. It's done the optimization. Escape. Let's check the printing's working. And I might print the cutting list too. Hopefully in a second we'll see the prints. Back from the printer, make it a little bit larger. There's the graphics of the optimized sheets. Multiple pages. And the original cutting list, which should look like basically the same list as that. Yeah. So all good. Well, I guess that concludes how DOS Emulator actually can work for you under a Linux environment. You've got the ability to talk to the RS-232 port. You've got the ability to talk to server drives. You've got the ability to use printers. And you can use new hardware that doesn't even have an RS-232 port to give you RS-232 port. Plus you've got a modern operating system that allows you to use internet, email, whatever, securely. So yeah, I think that pretty much does it. So I guess feel free to like, share, subscribe, ask a question, leave a comment. That's it. Bye for now.